Hey, are you interested in learning? Check out our videos. Want more knowledge content? Make sure you've subscribed to our channel.
When we talk about artificial intelligence, one of the most fascinating questions that comes up is, how does an AI actually think? We know it can process data, recognize patterns, and give us answers. But what really happens in that moment between input and output? That process, the one that connects understanding to action, is what we call reasoning and decision-making. Now, unlike humans, AI does not have consciousness or intuition. It does not sit and reflect emotionally on a problem. Instead, it uses structured methods to simulate reasoning, ways of connecting facts, probabilities, and goals to come up with logical actions. Let us unpack that step by step. When an AI agent receives an input, for example, a user request like, "Plan my day tomorrow," it begins by interpreting that request. It tries to understand what "plan my day" really means. Does it refer to scheduling tasks, checking appointments, setting reminders, or suggesting meals? This understanding process depends on context, which we discussed in the previous topic. Once the AI has a clear understanding, it starts reasoning, deciding how to achieve the goal. There are different levels of reasoning in AI. The simplest is rule-based reasoning. Think of it like following a checklist. If certain conditions are met, perform a specific action. For example, in an AI-powered thermostat, if the temperature drops below 20 degrees, turn on the heater. This type of reasoning is direct, logical, and works well for predictable situations. But modern AI agents go far beyond that. They use probabilistic reasoning and goal-oriented reasoning. Probabilistic reasoning means the agent does not always have perfect information, so it makes the best possible decision based on likelihood. For instance, if an AI self-driving car sees something ahead that looks like a shadow, it must decide, is it a pothole, a plastic bag, or a real obstacle? It uses probability and context to choose the safest decision. Goal-oriented reasoning, on the other hand, focuses on outcomes. The agent looks at the goal, let us say booking a flight, and breaks it down into smaller decisions like choosing a date, a destination, a preferred airline, and then confirming the payment. Each of those small decisions is made using reasoning steps that connect to the final goal. What makes reasoning powerful in AI agents is that it can be chained. This is what we call multi-step reasoning. The AI does not just make one decision, it thinks through a sequence of steps. For example, if you ask an AI system, "Find me the best laptop for video editing," it does not just search for laptops. It first understands what best means, maybe performance, price, and brand reliability. Then it compares options, checks user reviews, evaluates features, and finally ranks them. That sequence of thinking steps is reasoning in action. To make this possible, modern frameworks like LangChain, CrewAI, and AutoGen have something called chains of thought or reasoning chains. These frameworks let the agent analyze a problem, call tools, verify results, and even reflect on its previous decisions before finalizing an answer. This reflection is what gives agents the ability to correct themselves or choose better paths. Now, decision-making is where reasoning becomes action. Once the AI has reasoned through the available options, it needs to select one. Decision-making is not always about being right or wrong. It is about balancing factors like risk, efficiency, and outcome. For instance, consider an AI financial assistant that is deciding how to allocate investments. It might have data on stocks, bonds, and market predictions. It reasons about possible risks and rewards, weighs different outcomes, and then makes a decision based on the highest expected value. This process looks analytical, but it is also dynamic, because as new data comes in, the AI can reevaluate and adjust its decisions in real time. Another key element in reasoning systems is feedback. No reasoning model is perfect at the first attempt. The most intelligent agents are those that can learn from their outcomes. If a decision leads to a poor result, the agent records that, updates its reasoning patterns, and improves future decisions. This is similar to how we humans learn from experience. One fascinating technique being used in advanced systems today is self-reflective reasoning. Here, the AI literally reviews its own output before finalizing it. It asks itself questions like, does this make sense? Is this consistent with what I know? Or, is there a better approach? That self-review step dramatically increases accuracy and reliability. You can think of it as an internal quality check before presenting a final answer. Reasoning can also be distributed, meaning multiple agents can reason together. In large systems, one agent might handle research, another handles verification, and another makes the final decision. They exchange reasoning steps with each other, debate results, and converge toward the best solution. This type of collaborative reasoning is becoming very common in research and enterprise AI systems. Let us take a more relatable example: an AI assistant that helps plan a marketing campaign. It collects data about the target audience, analyzes engagement trends, suggests creative ideas, and even predicts the best posting schedule. Each of those steps involves reasoning, analyzing data, predicting outcomes, comparing alternatives, and making a decision. The more data it has and the better its feedback loop, the smarter its decisions become. You can see that AI reasoning is not magic. It is structured logic combined with data, context, and feedback. The agent does not feel or guess. It reasons, systematically, efficiently, and at massive scale. That is what makes AI agents so powerful in problem-solving and automation. The beauty of reasoning in AI is that it mirrors human thinking in form, but not in emotion. It allows systems to make consistent, unbiased, and explainable decisions, something that is often difficult for humans under pressure or uncertainty. So when you see an AI agent plan your schedule, write code, or analyze complex data, what you are witnessing is a structured reasoning process, analyzing the situation, weighing possibilities, choosing an action, and learning from the result. It is the closest we have come to simulating logical human thought in a machine.
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.lanetguide.net.